Okay, so here's where I'm going to show you how to do the one small skill that you've not yet done. So I'll use this chemical equation to get started. This says 2O3 yields 3O2, which looks kind of nonsensical. What the heck is going on there? But it turns out that the O3 is ozone and the O2 is oxygen gas. And the opposite of this reaction, the reverse of it, actually occurs every time there's a lightning strike, and that kind of crazy smell you can smell is the ozone that has been made. So, but there actually is a chemical equation between the two. You can take 2 molecules of ozone and convert that to 3 molecules of oxygen gas. So we can write fractions based on that. So the question we could ask is, what is the molar ratio between ozone and O2? Well, there's 2 moles of ozone for every 3 moles of O2. Now, right here he left off the units, but we would actually put 2 moles of ozone for every 3 moles of O2. And this is how we're going to be able to convert from ozone to oxygen and vice versa, is to make a fraction like this. If they ask you for the ratio between O2 and O3, well, then you could just write it backwards. For every 3 moles of O2, you have 2 moles of O3. So this is just a way to do a mole bridge, okay? And I can go from oxygen to ozone, or I can go from ozone to oxygen, depending on what is asked of me. So let's go ahead and do one of these from your homework. Okay, so down here at the bottom, we've got dinitrogen pentoxide plus water gives us 2 moles of nitric acid. So in other words, 1 mole of dinitrogen pentoxide plus 1 mole of water gives us 2 moles of nitric acid. So basically we can just do the same procedure we've been doing all along. It says how many moles of nitric acid. So we'll say question mark moles of nitric acid equals, what are we given? 0.75 moles of dinitrogen pentoxide. So let's just write that down, 0.75 moles. Now in stoichiometry, it's becoming important to write down the fact that it's dinitrogen pentoxide because we're going from one substance to the other. And it's really easy to get messed up if you don't write down what you start with. And we started with dinitrogen pentoxide. And since we started with that, we're going to go back to the equation circle because this is the one we need to know something about. And then we're going to nitric acid, so we're going to circle that too because this is the one we need to know something about. So for this particular equation, we don't need the water in our stoichiometry. We need it in the equation to balance it, but we don't need it anywhere in the fraction. We only need to circle what we begin and what we're going to. And that way we know that we need 1 mole of dinitrogen pentoxide, and we're going to 2 moles of nitric acid. And the 1 mole of dinitrogen pentoxide is going to go on the bottom so that it will cancel the dinitrogen pentoxide we started out with, and the 2 moles of nitric acid is going to go on the top so that it will be where we want it. So we cancel that, and now we can just multiply 2 times 0.75, which is going to be 1.50 moles of nitric acid. And remember, if we're remembering sig figs like our pretest has to remember, they only gave us 0.75, so I really should take that to 1.5 to make 2 sig figs like it should be. And there is my final answer, and that is how you would go from moles to moles. So anytime we're just converting from moles of one substance to the moles of another substance, we're just going to have 2 fractions, the opening fraction and the mole bridge. We're going to call this guy the mole bridge. So anytime you're going from moles to moles, 2 fractions is it. One you start out with, which is what you're given, and the bridge that you get from the chemical equation. And that's how you do the first part of stoichiometry. This is actually the 3rd step in stoichiometry.